All right, volume of a sphere. Quickly, let's see if we can do it. Sphere, hemisphere. Notice same radius. Get a cone, same radius as these. You can tell. Okay, we want this to be something we can hold, and we want it to be specifically the height of this is the diameter of this. They got the same radius using the hemisphere though. So 1/3 pi r squared h, we know that already. Pi r squared is the area here, multiplied by the h, take a third. Now we get this. Notice one of these fills up the hemisphere, so take 2 to fill up a whole sphere. So then we got the derivation. For a sphere and a cone, where the diameter of the sphere is the height of the cone. Remember, a diameter is twice the radius. Diameter all the way across, radius half that. Then, if that's the case, and they got the same radius, same circle, main circle, then the volume of the cone was the volume of a hemisphere, half of a sphere. And so 1/3 pi r squared h is our cone. 1/2 the sphere is this. Undo the half by multiplying by 2. So we get 2/3 the volume of the sphere, 2/3 pi r squared h. But remember, the height of the cone is twice the radius. So I put that in. And then 2/3 2 times is 4/3. So 4/3 pi r cubed. That's why. Cool. Kind of like a little calculus thing where we're getting little volumes and rearranging them, little layers or little tiny little bits. It's kind of what the water is. So that's why we have 4/3 pi r cubed. Twice this. That's one reason. There is a proof. There's other derivations in math and all this stuff, but a proof is relating something back to the evidence of the senses step by step, and that is what we did. A proof. So, hope you enjoyed. Peace.